Hi, we have more space. Let's continue. Okay, so we're gonna differentiate. So x over 2, say here, we're gonna differentiate that. What's the derivative of that? So we have the derivative of the top guy times the bottom guy minus the top guy times the bottom guy derivative, and then we have the bottom guy square, right? Here, the derivative of 4 is 0, so this guy is gone. Then we have x over 2, and then we have negative 4. The derivative of 4 is 0, derivative of x squared is 2x, and then we have 4 plus x squared. So 2 cancel. Our answer is negative 4 x squared over 4 plus x squared. So far so good, everybody. So this is the function that the power series converge to. Okay? Yeah. So you can see it can get very, very hard. Okay, so what is the interval of convergence? Well, then look at the power series. Let's figure out the interval of convergence. Okay, so use ratio test. Okay, R is limit k goes to infinity a sub k plus 1 over a sub k. A sub k plus 1 is, we plug in, replace k by k plus 1. Minus 1 to the k is gone because of the absolute value. And then we have the k become k plus 1. X to the 2, k plus 1 is 2k plus 2. Okay, so 2k plus 1 equals 2k plus 2. And then 4 to the k plus 1. Don't forget absolute value. And then we have k, x to the 2k, 4 to the k. Alright, so what is that? So k plus 1 is on top, x to the 2k, and x squared. 4k plus 1. So we can split the 4k plus 1 to be 4 to the k times 4. Okay, and then the denominator, so k, x to the 2k, and 4 to the k. Okay, so what can we cancel? Well, we can cancel x to the 2k, and we can cancel 4 to the k. Alright, so what's left? So what's left? We have k plus 1 and x squared over 4k, right? So when k goes infinity, k over 4k is 1 over 4, right? So this is what it converged to. Okay, so sorry, this is the limits of the R. And we know the series converges if R is less than 1. Okay, so what's that? That's the same as saying x squared over 4 is less than 1. So that's the same as saying x squared is less than 1 over 4. So it's the same as x is less than 1 over 2. Then x is between 1 over 2 and minus 1 over 2. So far, so good. But the ratio test only tells us that series converges when the ratio is less than 1. We don't know the endpoint. So we also need to check the endpoint. So when x equals to 1/2 and when x equals to minus 1/2, what happened? Okay, so what is the series? Okay, where's the series? Let me copy this down. Okay, so let me copy it down here so I don't need to go backward to find the series. I know this is a long problem. Yes. Hopefully you won't have that hard problems in the exam. Okay. Let me see. I cannot, let me see, what can I do? Okay, so we want to copy it, or like that. Okay, and then I can, okay, yes, I can do it here. And then let me copy down the series. Okay, it's here. Okay. Oh, so let me put it here. Okay. So you can see it. When we plug in x equals to 1/2, 1/2 to the 2k is like 1 over 4 to the k, right? So we have k from 1 to infinity minus 1 to the k, and this is 1 over 4 to the k over did I do something wrong? Yes, I do. Do you see my mistake? My mistake is here, when we multiply by 4, we actually get 4 instead of 1/4. So when we take square, we get 2, and then we get minus 2 and 2 there. So we actually get 2 and minus 2. Okay, so when we plug in 2 to the k is 4. So yeah, so we always need to check our answer. So 4 to the k and 4 to the k downstairs. Oh, they cancel. So we get series minus 1 to the k, k. Well, this guy diverges by the divergence test. You can see when k goes infinity, it is infinity, so it diverges. The limits of the sequence is not zero, then the series diverges by the divergence test. So when we plug in minus 2, we'll have minus 1 to the k, and minus 2 when we take the square, it makes still 4 to the k. And it cancels, we still have minus 1 to the k times k. It also diverges by the divergence test. Okay, so that's why at the endpoints it diverges. So the interval of convergence is -2 to 2. Okay, so far so good. And if we use another way to think about it, well, if we use another way to think about it, do you remember here? What do we start with? We start with a geometric series, and we recognize we replace x by minus x squared over 4. Okay. So this guy converges if minus x squared over 4 is bounded between minus 1 and 1. When we divide it by -4, become 4, change the inequality, and then this is -4, but it's the same as -4 less than x squared less than 4. We can take the square roots. When we take the square roots, it becomes like absolute value of x. You know, square root of x squared is absolute value, less than square root of 4, which is 2. Okay. So absolute value of x less than 2 is the same as it's bounded between 2 and the -2. But however, in the process of taking the derivative, we don't know about the endpoints. It might converge at the endpoints, it might diverge at the endpoints. So at the end, we still need to check at the endpoints whether it converges. Okay? So you might save the work of ratio test by just looking guessing the interval convergence of the original series, and then you can use this. But for the endpoints, you still need to check. Okay, everybody? So that is sessions 9.4. We talk about Taylor series. We talk about how to use the Taylor polynomial to approximate any given function. It's good to work with power series because they're just powers of x. We can differentiate them easily, integrate them easily. Okay, so we can another main use is we can integrate the power series of some functions, and we can approximate that integral. Even though we're not able to integrate many of the functions, but we can still approximate them using the power series. Okay, and that's it for chapter 9. Okay, bye.